Hello everyone. In this video, we will try to develop a small project in C programming language. This will be a very good exercise if you're already a programmer and you want to develop your skills in that field. So I will present the idea of the project so you can go ahead and try if you can solve it. And I will just go back to some basics in C programming language, and then we will try to develop this program together. So just like for to give you an idea about the project. So it's um it's a Vigenère Cipher decoder, like not just decoder but an auto decoder. So we will find automatically the password of the password used to encrypt our text. So we have a very long English text encrypted using this system, Vigenère Cipher, and the information we know is that we have lowercase passwords all smashed together, and the password length is between 1 and 100, and of course A is the most frequent letter in English, and the last most important point is like we need to use the index of coincidence to find the length of the password. So in English, it's 0.065, and in other language, it's the past. Like in French, it's 0.075 or 74, and that's it. So you can go ahead and try to develop this project. You have all what you need. This is the information. You can find the text in the below this video. And of course, you need to use C programming language because in other language you can find it can be more easier and less challenging because a lot of functions are already developed. So the idea is like to force us to like do it in C programming language so the like that we can throw many concepts like data structure, algorithms, and all of this. So I will just go back to present some basics in C programming language, and we will develop this project together. So as you can see, I will just present pointers, memory allocation, structures, and type def, input, output functions in C, and of course modular programming. So as you know, C is a very famous language. It was created in 1917 by Mr. Ritchie, the same guy who created the Unix operating system. And now C is like it's used in very so it's very widely used. It's used in many fields like operating systems, supercomputers, the microcontrollers, embedded systems also, and many other areas. So it's an imperative programming language. That means we need to specify to the computer what to do step by step. We don't have objects. We don't have it's not a functional programming language. Uh, so everything is like a step to specify to the computer. So I just given here an example. For example, allocate memory, ask users to enter a pass a number, multiply the number by 10, etc., etc. So some case, some keywords about C, like in general, we have 32 keywords. They are like basic, like int, char, float, double void for data type, short, long, signed, unsigned for it's like data type but modified. Autostatic external register are not really used, but it can be helpful sometimes. Most important control flow, like if else switch. I know, like if you're already a programmer, you know about those things. And then structures, like to define our own type, we can use struct type def to make our code more like readable and visible. Onion and enum for to create onions and of course enums. And we have also special keywords like cost, volatile, and size of. And this like project, I think we will use size of to specify the memory to allocate, and that's it. So, like, the superpower of C is like we have the ability to manipulate pointers. This can be dangerous sometimes, and if we're not paying attention, but it's very useful. So it's like very easy. A pointer is a variable that stores the memory address of another variable. It's not a variable that store a value, like for example, integer or a string. It stores like a memory address. How to define this variable? It's very simple. You can go ahead and like type it's like integer or character or double or even void, and we put a letter star before the name of the variable. Here, for example, the variable called p. And we use two samples. First, this sample here, it means address of the variable p in memory. And this means the actual value of the variable. So I will just go ahead and do some, like, show you some examples about how it's very useful and what to do and what not to do with those things. So I will open this code. So here, for example, I could just go ahead and put this in here. So in here, for example, we have a file called test.c, and I have the terminal to compile our my code and to run it. So I will just include some basic library that we will need. For example, http.h dot so int main, like that's mean like our projects will start from here or from like the this function, and we can put like those things because we will need them. Int argument C, it means that number of arguments that we will pass and a table of arguments. What that means is like when we call, for example, our program called main.exit, we will pass arg number one, arg number two, arg number three, etc. We will not need those things in this like example about pointers, but we will of course need them in this month for mini projects. So it's a good thing to know about this. And even you can know, like you can see that we use pointers. So like it's very very used in C programming language. So I will just like create a variable int called v, for example. um, like a pointer of the v, and another variable, excuse me, another variable called u, and I can store a value in files, for example, pi in e, and the value in v. Can do those things. For example, mine. So I'll just turn off this things. Good. So this is the same thing. So int star v and int u are both variable of type integer, but this is just an integer, and this can store address of an integer. It's actually others of an integer, but we actually can use them like in the same way, like just a variable. If we do those things, star v equal to 9, like it's the same thing to do those things. And we can test it like we try to print out and print, sorry, print like an integer, u, of course, and, and f, same thing, like star v. And if we compile our program GCC, so I use GCC as a like a compiler. It's the best one, and we can like it's executed successfully. So a dot exit. It's by default called a. So you can see like we have 5 and 9. So we can use them in the same way. But what also we can do is like we can go ahead and just try to show what is in the V. So if I compile and execute, like we have those strange integers. That means that this is the address where the value of V is stored. So this is very dangerous. For example, if we know the address of a variable, we can go ahead and change it, like it's the basic thing to do. And a lot of hackers use those things to, for example, crack a password or to change some memory data. And also what we can do is like we can go ahead and say like to v that like v is equal to address of u, and if we put, for example, like 5, same thing in u, and we go and put in v like 7, when we will show those things, u will be changed. We will not find 5, we'll find 7. And this is very, sometimes it's useful, but it's also dangerous. So we change the value of a variable that automatically change another variable. Sometimes we want to do this, but if we're like, of course, paying attention about what we are doing. Another thing to do, like why it's very useful, is like, for example, when we have a function that take like an integer, like a v, and it changed the value of this integer, for example, to 4. So if I go ahead to create a variable, and I will put like 1 in that variable, and I will call this function to change the value of my function v, the value of my variable v. So we will put 4 in this variable and not 1. When I'll try to print the value of v, I will not find 4. I will find 1. And why is because here we are not changing the same variable. We are changing a local variable that is created temporarily to for our function. So we have like a function that take a pointer and we will change the value of this pointer. So we have a normal variable and we will call the function v with that address of this variable and not the actual value. So we will not put v in here, we will put the address. And if we are try to print the value, we will find 4 and not 1. So this guy and we compile gcc test.c and a.exit and we can find 4. So this is very useful and we will of course use it in many cases in our mini project. So it's a good, very good thing to understand pointers and it's useful. But also it's very it's like very dangerous. So we need to pay attention on what we do and to pay attention on every variable that we created as a pointer. So let's go to the next point, which is memory allocation. So here is like it's like the same thing as pointers. Like here we just told the program to allocate some memory for us, and we have a lot of function. Malloc is like allocates memory, but like the memory allocated is not like all together. We can find some segment here and segment in another address that's very far away than the first one. And calloc is like the same thing, but like all the memory are smashed together. So it's like an array, like all the address are all together and all initialized by 0. Realloc is to reallocate memory, and free is very important, is to free the memory allocated. In Unix, we can use a program called Vagrant to for debugging and to find like the memory issues and something like that. In Windows, we cannot use this program, and also in Mac, we cannot use this one. So it's like just for Unix um, programmers. And next thing is structure and type def. So as I said before, we can define our own data type using structure, and we can use like in this like way struct the name of the variable and what thing we can like the variable can store inside. For example, the person can have 3 like felt. First one is like name, age, and height. And for example, in C, we don't have a type of date. So we can go ahead and try like subtract date, and we have like end hours, end minutes, end seconds. So it's very useful. We can do that. And type def is like to make things like look prettier and like legible and easy to read. And how to do it like type like just like this. We already created our struct and we just go ahead and type def struct person and name of the variable. And in the program we will not use struct person, we will just use person as like the type or the new type created. So another interesting thing about C is like input output file is like the to manipulate the files. We have a lot of function that already developed in the StudEU library. Like if open the function, the file, and we have a lot of modes like W is for read, R is for no, R is for read, W is for write, and we have a lot of other modes. If scanf is to read character from the file. If printf is to print something to the file, if close is to close the file, and we have a lot of them. Modular programming is like a way to make our code easy to read and easy to manipulate. We can go ahead and define some libraries, source file, file that store, uh, files that store like functions that like used systematically, main.c, like another file that is the main of our function, our program, and how to compile this. For example, we created a file on the library, and the main file we have like to call this file to use, for example, variable that's already specified in that library. We can go ahead and write gcc main.c source files.c. You can put source file number one, source file number two, etc., etc., and like minus o to specify the name of the program. So this program to run it, we will like type program.exit in Windows and to pass the argument. And so that's it. So that's it about like basics about C programming language. And like we will start to try to develop and to solve this mini project. So I already presented the idea of the project and all the information that we need and we have in order to find the password and ultimately to decrypt the text. And that's it. So I already presented the idea and all the information like we have and we need. And this is the main like strategy to follow to in order to develop this project. So first we have a main function that we'll call a normalized file. So we need to normalize the English text. Normalized mean we need to convert everything in lowercase. We need to delete every special character and every space and semicolon, for example, or any characters that are not between A and Z. And just after, we need to find the password length and password letters, of course. And to do that, we will use some function that we will, of course, code, like calculate index of coincidence, extract subsequence, get most frequent letter, and other function. And after we will like calculate the decryption key. Uh, of course, after like finding the password letters, we need to to decrypt the key to find like the specific password, and then we need to decrypt the text using like the password that we already find. So let's go to VS Code. Right. So here I already created some like this one, recycle bin. So this is the text like we need to decrypt. Like you can see like it's in English, but we can't understand anything. So we will, as I see, it's a very long text. You can see like hundreds and hundreds of lines. And we will first try to normalize this text. Normalized, as I say, like every uppercase will be were converted in lowercase. Every special character like space and this one will we will like delete it, and all of course numbers and digits, other characters, and like uh, like this one, for example, too. So let's like do this first thing. So I already present like with the modular programming. So we have a library, we have all the like just adjust a description to our program, and we have a library. So how did I define this library? So I just put those things if and if to define the library. The other library that I will need, the like the variable or the global variable that we need, for example, max iteration, or if you want, it's like the max password length, max password, sorry, max password length. Because in the text we know in the description of the problem, we know that the length of the password is, of course, less than 100. The coincidence index, we saw that it's 0.065, but we need like an interval. Um, so an interval, but we need like the minimum value and the max value. So I just chose this max value and this main value. And we have other functions that I will not show you how I develop other function that I will need. For example, is lowercase, is uppercase, upper to lowercase, get most next letter, the most frequent letter, count total letters, count specific letter, etc., etc. And this is just the the head of the function, and not the definition. The definition of those functions are in the tools.c. As you can see, I already included the library, tools.h. And this is how I defined all those functions. Is lowercase, is uppercase, like that. I think that you understand why this is like we have the bigger than A and less than Z. So like you can just go and look to the ASCII code in C to understand the basics of what I'm really doing here. And for example, next letter is a function that like to return us the next letter in a file, or return zero if there is a problem. Two, if the character is not like alphabetic, and one if the end of the file. You have this function get most frequent letter, like mean like the letter that is. So we see like A is the most frequent letter in English, but of course in the original version of our article, and the decrypted article, it's not A, not well, it can be A, but it's not. We are not sure. So we need a function that uh, work out the most frequent letter. For example, it will be A or don't know Z or something like that. And we have a function also to count the total letters of a file, to count a specific letter in that file. For example, letter X, how many X are in this file. For example, we will pass the letter X here. And another interesting function is extract subsequence. So we need to extract some information in the text based on the information we put here. For example, the key length and the start offset. And This is like the most interesting and important function in all what I just presented because, for example, we have a password like ABC, the password. The length, for example, is 3, because we have ABC, so 3 digits. And we have, for example, this is the text. This is the text. The um, trying to, etc. So if I told the function, so if I put this text here, for example, and but output files are just to like another variable to put the result in it, and the key length 3 and the start of it, maybe I will told the function to start from 0, so start from 0. So the return result return is I will return t, and every like letter that is in the position mod 3. So this position is 1. So 1 mod 3 is 1. So I will not return this one. 2 mod 3 is 2. I will not return this one. 3 is 3 mod 3 is 0. So equal to 0. So I will return S. And go ahead and go. So I return H, etc., etc. And this is for 0. Let's say like the start offset is, for example, 4. So I will start here like 0 mod, like 0 minus 4. So I will not like, I don't need to return those characters in 0, 1, 2, 3. I need to start here, for example, E. So this is why I define this position. So position, for example, here is 0. 0 minus 4 is minus 4. Mod 3 is minus 4. So we need to return this one. So here the result is minus 3. Here the result is minus 2, minus 1. And here the result is 0. So I will return A. And this one is like 5. So 5 minus 4, 5 minus 4 is 1. Mod 3 is is 1, so I need to return this one. This one, the result is 2, I won't return it. This one is the result is like 3, I will not return it, etc. So this is how important it is. So if you are like you feel like um, able to go and develop it, you can go and try to those all those kind of functions. And if you just want to go to jump to the main topic of our program, you can just use all of those functions. I will put it in the description below. So this is it about the library and the function that we will need. So the main function. So I just include all library again that we will need. And I just put here the name of the functions that we will need as I presented in the slides. So we will need a function called normalize file, function called calculate index of coincidence, find password length, password character, decrypt function, and the main. So what is the first thing to do? So the first thing to do in the main function is like explain to the user how to use our program. So I'll just go ahead and try if the number of arguments is equal to 3 because we need to pass like the input file and the output file. So 3 is because like the name of the program is also common. So I'll just tell the user, so if you pass a number of arguments like is different than 3, so I will tell them that this is how to use the function input file and output file. And like I will need to print this in the terminal so he can see the message. So this is it, and I will return like a flag that says like exit failure because our program is didn't started successfully. So then I need to define our variables. So I will need an input file, output file, um, the definition of the variable. I will need a normalized file. So file to normalize, says present before. We will need subsequence file, output file, an array to store the password, and 100 is like the max password length that I defined here. This one. And the end scale. So, for instance, for this moment, this is like all what we need. And let's start opening like the file. So the input file, we will call the open file, and it's the argument number 2, because in program we start from 0. And we need to put R because it's in red, like in the red, like mode. So I will just like test if the file is correctly opened, like if opened no, if input file is null, so there is a problem. So we need to exit the program. And we will do the same thing for the output file. So the output normalized file because it's another. So normalized file. So I will put this name. We will create this file because it's not, we will not pass it in the arguments. We will create it because it's a temporary file. We will delete it in the end of this program. And the same thing about normalized file and output file. I will not do the same thing for subsequent file because it's like for just for like specific function. We will use in a specific function, but we will do the same thing for output file. In like mode and if everything is like uh, correctly everything is correctly uh, good, we will pass to the next. If not, we will need to close all files. And of course, for this one, we need to remove it, remove my text. And just check for the normalized file. So if close, that's good. And so that's it. So we open the file. So what to do next is we need to normalize our text. So step number one, like normalized file. So we need to call this function normalized file. This function we have the like the name, but we are we haven't defined it yet. So let's define this function. So basically, what normalized function do is it scan the input file. So to in order to do that, we need a variable called C, and we will just use rewind because it's very important to use this one. Rewind, which actually mean like we need to reinitialize the pointer to the beginning of the file because when we start reading on the file, it's automatically passed to the next letter or the next character. So we need to uh, uh, go and return it to the first or the beginning of the file. So we'll need a while loop, and we will use if scan f, if scan f, the input file, and of course the mode is C, and we need to put it in the C variable. So this function returns one, so we can go ahead and look at the type of this variable. So if it's um, uppercase, it's uppercase, case. Mhm. If C is uppercase, so what to do? We need to print it. F print F into the output file. Of course, the mode is sorry, the mode is C, and we need first to return it to convert it to lowercase. Oh, sorry. This is if it's uppercase. If not, if it's lowercase, we will just print the same thing. And else, like if it's not an upper or a lowercase, we need to just ignore this connector. So this is it for the normalized file. It's very easy. If it's uppercase, we convert the character to lowercase and we print it to output file. If it's lowercase, we put the same thing. If it's another character, for example, space or another number or something like that, we will do nothing about it. We just pass to the next one. So this is normalized file. So let's see if everything worked correctly. So normalized file, and that's it. So let me just look at those. So in order to test this, we just put all of this in comments to compile my code. So, oh, good. So I will try to create this file in order to say if to to test if our code is working correctly. So go ahead and compile this text GCC, as I said, main.c tools dot so let's compile our file. So as I said, main.c tools.c minus o program. So we have a small problem. What is the problem? Normalized file is not a function or function pointer. So, okay. So how did we define that? To take like an input file and an output file, and normalize file, it take input file and output file. It's the same thing about this one. We don't have anything here. Ah, the problem is like we we have like a variable that has the same name to the function. So let's just rename this variable to normalize text and like the same thing here, like normalize text of open normalize text and up the same okay normalize text. Perfect. So let's recompile the code. Normalize. Okay, there is nothing. Forget this one. Normalize text. Continue. Good. So it's compiled successfully. So let's just run the program. Run and the encrypted text encrypted, and another file like for example output.txt. So let's look at the normalized file created. So this is normalized.txt, and you can see the text is totally normalized. There is nothing such as space or special character. There is no uppercase, just lower cases all together. And in the output file, we have nothing yet because in the main, we didn't specify what to do with it. So everything worked correctly, for instance. So let's move to the second step. So the second step is to find the length of the password. To find the length of the password, we need to first, like we need to um, create this function to calculate or to work out the index of consonants. But we'll just name the step like determine the key length or the password length. So to do this, actually to make things like look very good, like we can just print. So this is the first step, normalizing file, and here print like this is a step to determine the key length. And we will first call the find password length, and we will pass the normalized field. So let's define this function. So it's in the command here. So oh, just hit this one. So we need to define this function here. Find password length. So this function actually will use the index of coincidence in order to find the password ones. So the first thing to do is we need first a file uh, called subsequence. Okay, find sequence, subsequence file, subsequence file. And we will need another variable type double called index of coincidence or coincidence index. We'll start with like 0, 0.0. And then we need to start a for loop to actually extract subsequence and calculate the index of coincidence for each subsequence. So let's start the for loop. So it's the like normal like it's less than max password length e plus plus and it's still that's like is away max password length e plus plus and after we need to extract subsequence. So subsequence variable this one subsequence variable will equal to um, we need to open a file, sequence.text, and then we need to like just test if everything is working correctly. We need to return so return an integer, so we need to put -1, and then what we need to do is extract subsequence. We call this function. We will put the input file. It's the normalized file, input file, and then the subsequence file that we just created, subsequence, this one, subsequence file. We need to pass like the the key length. So for example, so the definition tells us to pass the key length and the start offset. So the for loop will pass 0 to 100. So we will actually test every key length to in order to find like the best index of coincidence. So we will say like if the key length is 0, so we will work out the index of coincidence. If it's below 0.065, we'll go to 1, 2, 3, go ahead to the 10. 1000. And why 1000 is like sorry, it's not like 1000, it's 100. It can be 1000 if the password is like the 1000, but in the text they told us that it's 100. So I will just put here 100, like 100 iteration, and we will start from 1 because there is nothing such a password with length 0. So we'll start here with A and the offset is 0. And then we need to close the subsequent file. And what to do next is we need to like open the same file. So sequence file mhm, equal the same thing but in read mode and like the same thing we test if the file is opened correctly. And we need to work out the coincidence index. So the coincidence index will calculate coincidence index of this file. So this function we have it there here, but we will like we it's not defined, so we will define it just after. And we need to close the file again, close, subsequence, it's not close, so close, okay, close subsequence, and um, let's just print like a small message to tell the coincidence index calculated in this context is like this one. So with 6 digits. And we actually don't need 6 digits, we need just 4, but 6 digits like for more accuracy. And this is the test, like here we will use those variables like we created before, index of coincidence, max and min, to say if like to test if this length is if A is like the best length or not. So if coincidence index is like between coincidence index is between like bigger than sorry bigger than mean coincidence index and less than max coincidence index. So the possible k found is A and we will return it. And if not, like we will just return 0. So no valid for comments. So what we forgot to do here, like this, we need to like define this function, calculate the index, the coincidence index. So this is a very like a very easy function to do. If we are looking like just look to the definition of this one, you can see like the coincidence index is like the probability to find two characters that are the same that we pick out uh, randomly in the text. So this is the formula. It's very easy to to understand. And for each language, we have the number, the coincidence index. For example, in English, we say like 0.065, French 0.057, and other language. So we will go ahead and implement this function, mathematic function, in a C programming language function. So first um, we need a variable of type long. It's a very big integer. So we need a total number of letters. So we need to call this function count total letters of the output. Then we need another uh, like another variable, letter occurrence, letter occurrences. Hmm. It's not like it's not a table, it's just like a variable. And uh, and another one, like it's coincidence index like 0.0. And like let's just start with some if it's equal to 0. The number of total letters like in the text is 0, so we need to return that the coincidence index is 0.0. So like to avoid division by 0. And mm, and actually we can put like less or equal to 1 because even 1 is not like that a lot. And after we need a loop function, a normal one, that start from E to Z and like use on those things. What we need to do is like to count specific like for each character, so letter occurrence equal count specific letter. This function is already defined in tools. So input a plus uh, I. So a plus I start from 0 to 26. So this function actually will go ahead and start from A to Z letters because this, like, if you understand the ASCII code, you know that like A plus 1 is B, A plus, for example, 25 is Z. So like it's the same thing. And then we need to like to work on this thing, considers index, like what's of type double letter occurrence, and we will multiply it by letter occurrence minus one. It's like it's this for loop is like the same thing like in here, like in the sum. It's like the this function. And we put like number of occurrence multiplied by number of occurrence minus 1, and we will do it 26 times. So this is it. And just after we need to return the consonant index divided by the total letters multiplied by total letters minus 1 is like what you can see here, n multiplied by n minus 1. So this is it. Um, mm, mm, and just forgot this one. And uh, everything is already defined. So this function count total letter is already defined. Count specific letter is already defined. So everything looks good. So calculate index of coincidence is good. Find password length. We already did that. Just a small problem here. Thank you. This one is for I need that. I need like to close this one. Mm. So good. So this is like to find the length of the password. So let's like test the function is work correctly, and let's like print like the determine key the like the key length is if it's we will work out the key length to see if it's a good one or not. So let's like recompile the code just to see it's in. There is no problem, so it's compiled successfully. And let's go ahead and execute it with the same thing. So program.exit text encrypted.txt output file.txt. So normalizing the file input, good. Determine the key length. So here you can see like this is the for loop. Here we calculating like the coincidence index for each length of the password. So password will live, with the length one has a coincidence index of 18. So this is not good. And we will go ahead and try for every single one to find like the best coincidence index. Here we find like 0.067. It's uh, like bigger than 0.065. So this is what we are looking for. Why this is we didn't take this one because 0.039 it's very very below like 0.065. So now we know like that like the password length is 45. The number of digits in the password used to encrypt the text is 45, like 45. So good. We are like in a good like way. We already did like the most difficult part of this project. Now we need just to use like this value calculated here to find the exact like digits or the exact letters on the password. So like the next step, the step number three is identify the password. Number three, step number three is to find the password character. So to do that, we will first like print for to the terminal. To do that, we need to call the function find password characters. We need to pass normalized file, subsequent file, password, and the key length. The password is like the variable that we created here for this is like an empty array. So that's it. So we need to define this function. Well, so what does this find password character do? So here in this function, we will actually use the information or uh, the fact that A is like not A but E is like the most frequent letter in English. So we will use this like idea to find the exact password. The simple like way is to look at the normalized text and find the most frequent letter and then subtract this letter to A to find the original letter. So let's go ahead and do it in a very easy way. So we will need a variable E, for example, like for our loop shifts, of course, and like that's just a command on like each character of the password. We will go ahead like that. mm, I really like to print it like a message to show us like we are like doing those things. In the terminal, you can see like those messages are really helpful for us for debugging and to understand what the codes actually do. So let's like open the subsequent that we call the passive here. If open, we create a text file in write mode. And then we need a loop, uh, none1, equal to 0, start from 0. So E less than the key length and E plus plus. So first we need to rewind, like reinitialize the pointer for the normalized text, this one. And the same thing for subsequence. So rewind like subsequence file. And then we need to extract subsequence according to position in the password. Extract e minus sub e subsequence. Sorry. And we need to call the function extract subsequence normal file to this file and key and key length and offset. And we need to do the same rewind subsequence file. And then let's find the password. So find password, most frequent letter in subsequence. And like password, like password E, called get to most frequent letter in subsequence that were created here. Because extract subsequence actually we put the result in subsequent file. And in this file, we will look to the most frequent letter, and then we will store it in the according position for each letter. and like let's close the subsequent file, and let's calculate the k actually. Calculate the mm, we need to calculate decryption key. Not this. Calculate the crypted decryption key. Assuming that. Um, so let's just print like this one. So to understand what we are doing, like we're actually filling this table with letters that uh, are frequent in each subsequent file. Because here we actually work out, um, so key length is, in this case, it's 40, so it's 45. So we will have 45 subsequent file. And each file, we will look to the most frequent letter in the subsequent file, and we'll put it in the password table. Like here we put A because we are doing this for the first, like for the first offset, the second, the third, although to the 45 ones. So we have the table, the password table filled with all the readers, and now we need to find like to do the like the subtraction. We need to do the subtractions from the E because E is the most frequent letter. So this is easy, just like calculating the decryption key, and we need a for loop, of course. E equal to 0, E less than the same thing, E length, and E plus plus, and oh, sorry, plus plus, and we need oh, we need to like calculate the shifts, like shifts for password minus E. And then if the shift is length less than 0, shift plus 26. If not, we will just put the password E plus shift. And that's it for like the decryption key. And like we need just to print to the user that the password decryption password found is this one. Um, pop, 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 like this one, yeah. This is how we print the password. And I think that we're good. Like just print this one. So we don't have, we will have a pretty nice place. So everything looks good here. Like, we are extracting subsequence. We are getting the most frequent letter, and then we are calculating the decryption key. So all looks good. So let's try to do that. Find the password. So first recompile my code, refresh the C, and that's good. Let's run it. So normalizing the input file, determine the key length. So let's work out the same thing. Let's use index for each length of the password to find the length of the password. So we already know it's 45. And then in the end, we will actually see like the actual password. So yeah, and finding password characters, and and that's it. Calculate encryption key. So derived password is very good job. This is the code you have been looking for, and this is the code like used to decrypt our text. So as you can see, we're like going step by step to by finding the length and then the password. And now the only thing to do is like to shift all the text to the original one using this password. So the last step is step four. Step four, decrypt text. And we just print this one and we will call this function. So we will put normalized texts and output file and password keying. And actually, we will not pass because it's like here we will decrypt the text. So we need to get the original like data, for example, the spaces, like the special characters and everything. And normalized text doesn't have built-in, so we need to put like input like the original one, the input one, the one that like this one, input file. Good. So input file. And like we need like the output file and the password like we found and the keying of this password. And that's it. So let's define this function, what it does. So actually the decrypt file is very easy. We need just to reorder everything. So rewind input like the same thing we did before. Uh, like variable to read text, so letter and text and letter and text. Like we need after a while loop, and we will scan the output file, the input file. So if scan f like the input file, like oh, C and the others will C. And if it's like equal to one, we'll go ahead and um, do those things. Or we need to or we need a shift variable, and then we need like f the is uppercase is C. So like if it's uppercase, shift equal to passwords letter x mod like, oh, mod key size. I will explain all of this. Key size so minus like minus a. So actually what am I doing here is like so what I'm doing here is like I will scan every single character from the original text and I will like look if it's uppercase. So if it's uppercase, so I need like to I need to like find the shift first. I need to find the shift, and then I will print f to the output file the this character minus a big one because it's uppercase minus the shift plus 25 mod 25 plus a. This formula will find like the letter with the exact like if it's upper or lowercase like here it's uppercase so we will find we'll turn it like if it's uppercase we will turn it to uppercase and like the exact like letter shifted by the password like we passed before and this is how we like we get the letter like we need from this password. And if granted, we put it in the output and then like just leaves letter and x plus plus. So letter and x mean like we to know like the position from the password. So else if it's lowercase, so we'll do the same thing but like we change those things like a here in place of the bigger one. And else, like if it's like not lowercase or uppercase, we'll just write it like the same as it is. So not alphabetic characters, alphabet as it is. So I think that we're good. So this is going like this one, this one. Need to close this. So everything looked toward good. So let's try. So before that, I need to like do some cleaning. We opened a lot of files, we allocated a lot of memory, so we need to load files and remove them. Example. And so, yes, this message to tell the user that like the not this one, to put like to tell the user that the he can find the result in the argument number two. That's mean in the output file. So let's go ahead and try all of these. So let's compile and let's run our program. 24, 25, good. We find like we already find the password. We know it's like very good job. This is the code you have been looking for. And decryption complete. Output written to output.txt. So let's see the file output.txt. As you can see, so we move from this text that is not really understandable to a text that's completely understandable and it's the same and it's like has the same thing like special character, space, the semicolon, everything. So this is it. This is like how you do an automate decryption program using C programming language. We had like go through many important uh, characteristic of C programming language and many other concepts in mathematics and in cryptography. So I hope you like this video and that's it. Thank you for watching.